My name is Maura McGinty-Kloss. I am the Natural Areas Association Director of Programs and Communications, and I'm delighted to welcome you to today's webinar. The purpose of NAA webinars is not just to convey information, but to engage natural areas professionals on topics of interest that highlight emerging science and methodologies and best practices. And I encourage you to participate in the webinar by posting comments and questions in the chat function, and we'll address as many as possible as we go through the program. Also, if there is a topic of interest that you would like to see in a future webinar, please don't hesitate to let us know. You can contact us at info@naturalareas.org. So for those of you who don't know us, the Natural Areas Association is a national nonprofit organization that serves practitioners who manage ecologically significant landscapes to protect biodiversity. Protecting natural areas in perpetuity requires quality science to inform practices and access to reliable resources. And that's where NAA comes in. We provide science-based content for natural area practitioners and researchers seeking applied science, practical solutions, and knowledge transfer related to the management of natural areas. And we provide a suite of programs like this one today, as well as conferences that are in person and workshops that are a broad spectrum of current and emerging issues. So we design our programs so that they achieve on-the-ground outcomes and encourage practitioner participation, because we know that so much is learned when you all talk to each other. If you would like to know more about NAA program, please feel free to use the QR code that's on your screen. It'll take you to our website. And then before we get started, I just want to talk a little bit about the Natural Areas Journal. So the Natural Areas Journal is published 4 times a year, January, April, July, and October. It is a peer-reviewed journal that is available on Bio1. And the Natural Areas Journal includes writing on conservation issues, forums, topic reviews, editorials, state and federal natural areas activities, and book reviews. And our editorial staff is currently accepting manuscripts. So I know you're all busy, but I just want to remind you that sharing your work is something that's valued by all of your peers. And if you aren't ready for a peer-reviewed manuscript, I just want to remind you that we do have something called Stewardship and Action articles, which are a great option when you have some new insights or an innovative methodology or some just observation that you want to share. Too busy to write it yourself? Contact us, because we do have some people who can support you in that effort. The more important thing is that we get the information out there. So now I want to turn our attention to today's speaker. Thank you for going through all that with me. So Julia Michaels will be talking today. She has completed her Ph.D. in ecology at UC Davis, where she focused on research and strategies for restoring native California vernal pool wetlands. Prior to joining Hedgerow Farms, Julia served on the faculty at Reed College in Portland, Oregon. She loves working at Hedgerow Farms because it's her favorite way to connect with the public about the importance of conserving native plants and to help practitioners apply the best available science to their restoration projects. So Julia, I'm going to hand it to you from here.
Okay, well, hi everyone. Thank you so much for the introduction, Moira. Again, my name is Julia Michaels. I'm the restoration ecologist for 2 seed companies, Pacific Coast Seed and Hedgerow Farms, which are both based in Northern California. And I'm just so honored and excited to share with you today some research on post-fire seeding. And this is work that was done a little before my time by David Gilpin, Bill Agnew, and Chris Swan, who collaborated. It was a collaboration between our seed company, an environmental consulting firm, and the East Bay Municipal Utilities District. So it was a public-private partnership. And the reason that we as a seed company were involved in research is because we're always trying to do more than just grow and sell native seed. We act as a consultant on many projects across California. We're doing consulting on big, small, private, public reseeding work. And we're more than just a native seed farm. But before we get into that, I do want to tell you a little bit about our farm. Hedgerow Farms is in Winters, California, right outside of Sacramento. And we were founded in 1989, and we have about 300 acres of native forbs and grasses, and we grow about 100 different species of native grasses and forbs. And so you can see it's very beautiful in the springtime, and if you're ever in town in Northern California, I highly recommend you come out and visit. We would love to have you. So as you can see, we are sort of located in a matrix of a lot of monoculture agriculture. And you can see sort of from this map on your right, Hedgerow Farms is right in the middle, and to the left and to the right of it are walnut and almond farms, as well as grasslands. And so I have a little animation showing how over time, we are supporting a huge amount of crop diversity, rotating our fields between forbs and grasses, rotating out the species. And, we do this so that we can provide a huge amount of diversity to our clients, and also make sure that we're staying, genetically true to the wildland sources where we originally get these seeds from. So my husband said I should put some disco music to that, that animation. Maybe I will next time. Again, some more beautiful photos of the forbs, although, what's really missing here are the grass fields. And we do have a huge amount of native perennial and annual grasses that we provide. So, we've done historically a fair amount of post-fire reseeding work, but it gets a little bit tricky in California. So, in other places like the Great Basin and maybe on the East Coast, there's, less concern about post-fire reseeding, but in California, it's pretty complicated. Does anybody have, any reasons why post-fire reseeding might be complicated in California or in the West? Has anyone come across some challenges to post-fire reseeding? Issues of water, right? Yeah. Shrub responses. So, we have problems with trying to establish seed during droughts. Yeah, so rain washing the seed out, local regulations, right? Definitely. And then, yeah, somebody hit on it right away, the introducing invasive species and seed mixes. So we do have, especially in California, a history of reseeding with non-native species. This has been something that, the Forest Service did in the past. And it's caused a lot of sort of mistrust amongst land managers. And yeah, too many players delaying decisions. That's another really good point. There's so many different agencies, so many different stakeholders that have, ideas of what the best post-fire recovery approach is. And so managing all of that can take so long that you kind of miss your window. Invasive species contamination in seed mixes. So even if we're attempting to reseed with natives, if we don't have good, clean lots of seed, we can accidentally introduce invasive species or weeds into, wildland environments. And that is something that is really challenging. There's also, the problem that research has shown that it's not consistently effective. So that can have to do with, what some of the other people in the chat put in about, timing of precipitation or the seeds getting washed away. Someone just mentioned that even native reseeding can suppress the flush of post-fire early cereal species. So the idea that even if you put native species in, there are still seeds in the seed bank that could be coming up naturally. And that's kind of this idea of active versus passive post-fire restoration. There's a lot of debate about, should we be intervening post-fire, or should we let a system sort of recover on its own? And so active would be going in and reseeding or doing some restoration work, and passive is sort of, maybe doing some basic earthwork and then letting the plants come in themselves. So the California Native Plant Society is sort of the, not the authority by any means in California, but it definitely has a lot of sway in what resource managers think about how to approach this. And they came out with this fire recovery guide, and it really cautioned against using native seed in post-fire restoration unless you're very careful. And so this guideline said that, we do not recommend this practice unless specific erosion control and natural regeneration issues necessitate the use of native perennial grass seeds and or mulch without weed seed. So, reading this, you would think, okay, well, maybe we should just leave it completely, don't touch, reseeding. But when you talk about, okay, erosion control issues, that's one of the hugest challenges that we have post-fire in California. So a lot of times this specific erosion control and natural regeneration issues come up, especially because we have so many non-native species that come in post-fire that we're working on trying to suppress. So here's a list from that same fire recovery guide of, the many, many very noxious non-native species that can come in post-fire. And so in some cases, we want to be reseeding not only for erosion control, but also to try and kind of hold space against those non-native species that could be coming in and taking advantage of the disturbance caused by wildfire. So as I said, post-fire reseeding is complicated. And, as a seed company, I wish we had all the time in the world to be doing research. But unfortunately, we're often just filling orders and trying to work with clients. And so, the best that I can do is present to you a case study. And a case study is really different than the academic research I did in my dissertation because it's not perfect, but it's a chance to learn from the real challenges and the constraints that, our practitioners have when they are trying to do this type of work. And if we treat every project as a case study, that can really increase the amount of information we have to go off of. But before we get into it, I did want to share with you some academic research that I came across in sort of my education about this. And something that's really interesting is there's a trend towards looking at post-fire reseeding as a positive approach once again. And so this is a paper that was published just in 2019, looking at how seeding native species increases resistance to annual grass invasions. And they found that basically seeding perennial species after burning decreased invasibility in sites with low resistance. So this mixture of shrubs, forbs, and grasses actually was able to keep cheatgrass, Bromus tictorum, invasion to a minimum. So this is coming out of course, the Great Basin, but is applicable, to many other places in the West as well. Similarly, this was a really interesting article that just came out in June 2022. And this actually looked back on a lot of the research that had found that active restoration post-fire, particularly reseeding, was not effective. And there was this sort of consensus, or not consensus, but starting to think, okay, well, maybe this isn't worth it. But this research that came out in the Journal of Nature, which is a really big journal, found that looking at 1,500 wildfires, they found this disproportionate focus on areas with stressful, degraded ecological conditions. And so this led to, the conclusion that treatment was not effective when they weren't sort of taking into account in their models the fact that these were the most stressed, most difficult areas that were chosen to reseed, right? So if you had a perfect world where you were a scientist, you would just randomly assign seeding treatments, but that's not really what happens in the real world. The areas that are the worst off get addressed first with seeding. And so that, that factor, that failure to incorporate these unmeasured drivers of treatment allocation led to the conclusion that costly, widespread seedings were unsuccessful. However, after considering sources of bias, restoration positively affected sagebrush recovery. So I thought that was a really interesting article, and you all are welcome to look into it. I believe Moira put the links in the chat. And then finally, one more. This is a more broad global meta-analysis that looked at how different post-fire plant recovery strategies vary with shifting fire seasonality. So one thing we know is that wildfire has changed a lot because of climate change. So some fire adaptive systems that we would assume would be able to recover passively due to the natural capacity within its seed bank, et cetera. When these fires occur out of season, that reduces the ability of these areas to recover. So they found that fires outside of the historical fire season may lead to decreased post-fire recruitment, particularly in obligate seeding species. Okay, so I hope that I have primed you all to be open to the idea that post-fire seeding is something that is worth exploring in your respective areas. And I'm going to present again a case study that is not nearly as polished as these papers, but we can still learn a lot from. So if you think back to 2015, which is already, quite a few years ago, this was sort of, in my memory, when I start to think of like the mega wildfires in California. The Butte Fire was one of the ones that comes to mind. And it was a huge, very costly, very dangerous wildfire in Amador County, which for those of you who are not familiar with that area, I don't know, can you guys see my pointer? All right, well, it's sort of to the east of Sacramento. And this fire burned about 71,000 acres. So, a very large, very hot wildfire. And this is kind of what the area looked like post-fire. So the soil was just charred, everything was taken out. This is not the sort of low intensity wildfire that might be regenerative for a landscape. This was kind of nuking the area. So we might consider this a good candidate for post-fire reseeding for several reasons. One was it was high severity. The other reason was this was early season. So, when you are able to reseed early in the season, and for us, that would be, late fall, not, I'm sorry, reseeding before the rains, you are able to, get better establishment. The slopes were not too steep. And there were erosion control concerns. So the CNPS's concerns about, when is best to apply native seed, this I think would very much fall into the category of, worth looking into for reseeding. And there were invasive species concerns. So our two questions were, does seeding after fire increase vegetation cover? And does seeding after fire reduce sediment loss? So those are the two sort of factors that we were interested in looking at, not only because, we wanted to see how our seed mix did, but also because these are the goals often of post-fire management. The third question that we would have liked to ask was, does seed application method matter? Once you put seed down, it's really good to put some organic matter over it. So, we wanted to test something like, rice straw versus wood mulch, and then a fall versus a winter application. Because as you know, in our Mediterranean climate, we have, very hot, dry summers and very cool, wet winters. And so, if you were to seed somewhere in August or September versus December or January, you'd have a very different environment that you're seeding into. So here's a map of where our 3 treatments were applied. You can see the control is sort of over on the right in blue. And then we had 2 plots of our 2 different treatments. We had our fall seed and straw, that's SS1 and SS2. And then we had a winter seed and wood mulch. And so for those of you who have training in experimental design, you'll notice right away that this is an issue because we can't disentangle the mulch type and the timing with this study design. So this sent my head spinning because, as someone who's designed experiments before, I thought, man, this is, why don't we have one of each treatment and one of each time? But that's just the constraints of working with multi-agency collaborations and trying to get the timing right. So this is what we've got to work with. And there's still a lot of really interesting conclusions that we can draw from this. So again, fall seed and straw, winter seed and wood mulch, and then our control where no treatment was applied. We applied a native seed mix, which we grew at our farm at Hedgerow Farms, and we use local ecotypes. So we tried to source the seed from the wild close to where this fire occurred. Of course, we didn't actually go out and do contract collections from that area because there was no seed, but we did have quite a large inventory that allowed us to get the seed closest with the idea that this seed might be better adapted to the environment if it came geographically originally from where we sourced it. So we had a mix of grasses and forbs, and we lab tested them for weed species to make sure that we were not introducing any noxious species into this wildland environment. Here's a table of our seed mixes. So As you can see, the mixes also differed slightly between the fall and the winter. Specifically, we didn't have the 2 lupin and yarrow species in our winter mix, but we did have them in our fall mix. But I wanted to sort of walk you through what we normally do when designing seed mixes. We start usually with our workhorse species. So these are species that are kind of ubiquitous. And some of you from outside of California will recognize some of these species like Bromus carinatus, Elamis glaucus. And, these 2 perennial grasses are really hardy. They can do well in a large variety of soil types, and they establish quickly. We also included Festuca microstaches, which is a native annual. And sometimes we use that almost as a cover crop because it, seeds really well and fast the first year and maybe the second year, but then kind of peters out. And so it's a really good sort of cover crop situation. And then we have, a long-lived perennial in there, our Stipa pulchra, which is the California state grass. That is a bunch grass that can live for, decades. And so over time, it takes a little longer to establish, but over time, Stipa does tend to establish and hold space. And then finally, we had trifolium in both of those species mixes so that we could get some nitrogen fixing and pollination services as well. And the lupin was only in the fall mix. Okay, so how do we apply the seed? Let's see. Can you write in the chat some ways you know of how to apply seed to a natural area? Aerial, so dropping it from the air. Yeah. What else do we have? Hydroseeding. Yep, so we'll go over that for sure. No-till drill. Perfect. Yeah, there's so many different kinds. Hand broadcasting, so many different approaches and so many, mixes of approaches that can be appropriate for your site. So we're just going to go over just a couple. Drill seeding, some of you all mentioned. This is using basically traditional agricultural equipment as a wildland seeding technique. It really works best in flat areas, although maybe some of you all know better than I about how to use it on slopes. And it can be hard to calibrate, right? These seed drills are generally made for seeding uniform mixes. And so it can be a little hard to work with, but totally doable. Not for us, though. This is a steep slope. We're not about to be able to get equipment out there. Hydroseeding, somebody mentioned, that's a great post-fire technique. And you've probably seen it, driving down highways, this sort of green slurry, which is a mix of tackifier and bonded fiber matrix and seed. And one of the things we've learned from consulting with clients over many years is that it's best to do a 2-step approach. So one of the problems is that only about 1/3 of the seed, if you mix it all together, only about 1/3 of the seed is going to actually touch the soil. The rest of it is going to get suspended in that hydroseeding slurry, and it'll dry out, and the roots will never be able to reach the soil. We need to increase seed to soil contact. So we recommend to our clients that they do 2 phases. One phase where they take all the seed and they mix in just a little bit of the mulch and tackifier, just enough to get it to stick to the slope. And then they go over a second time and install the rest of the mulch and tackifier. So a 2-step approach. And that's something I'm constantly recommending, and it seems to be working better. Y'all can tell me, what your experience is with that. Or hand seeding, as some of you mentioned, hand broadcasting. And so for this case study, we actually went ahead with hand seeding. Even though it's quite labor intensive, we had quite a bit of labor, and it allowed us to really have more control. It was also difficult to get hydroseeding equipment out into this kind of remote location. So we went and hand seeded for both treatments, both the wood mulch and the straw. So again, our 3 treatments: fall seed and straw, winter seed and wood mulch, and our control. For our rice straw mulch, we applied it at 3,000 pounds per acre, hand applied. It was a lot of work. We did 36 acres total. And we had crews going for, several weeks doing this. But again, it was what we had available, and we understand that that's not necessarily something that people can do. But it's interesting to see see this approach versus our winter seeding and wood mulch, we actually applied aerially. I stole this photo from a different project because I didn't have any good photos of our Butte Fire seeding, wood mulch. But that's basically what it looked like, helicopters dropping wood mulch from above at about 4,000 pounds per acre, aerially applied. And yeah, this is from Colorado, this photo. Oops. So again, our straw mulch and seeding happened October 25th. Our hand seeding and wood mulch happened January 25th, 2015. And so here's a hydrograph looking at our precipitation. And so I kind of talked about how the timing of seeding can be so important. So our fall seed and rice straw occurred right before we had, a series of many rain events in a row. And that's what we're really looking for. We want consistent rain events that will germinate the seed and then allow it to establish, versus our winter seed and wood mulch, unfortunately, happened right before, a rain event, and then we got nothing for, quite a while. And so, that definitely, that timing, I would say, if I had to guess, would be the stronger influence over the success of these two seeding events rather than the rice straw versus the wood mulch. That is, not empirically tested. I just, given this hydrograph, given what I know, I would say we were really more testing the temporal effects of seeding than the mulch that we put over it. So the question, does seeding after fire increase vegetation cover? So here's our control. So October 23rd, 2015, that was when we, first took photos of this burned site. November 12th, still looks pretty much the same. By April 8th, we had some perennial forbs regenerating, but it was still, tons of bare ground, just kind of ripe for, the invasion of non-native species. And so, it doesn't look like much has come back, but, you'd have to kind of wait and see. Our seed and straw looked really great after our first year of application. So we applied it in we applied it November 12th or October. And then by November 12th, it was, kind of starting to germinate. And by April 8th, 2016, we had really good cover of perennial grasses and that annual Festuca microstaches. Okay, so I know I'm missing a photo here. We didn't take a pre-photo. January 2016 is when we did drop the seed and mulch, wood mulch. And you can see in that photo, the wood mulch barely covered the seed. I mean, even with the high rate we were applying it at, you really just didn't get a very good cover of wood mulch. So I don't know how much it actually did to protect the seed. You do see seed starting to establish though by April 15th in 2016. So you can see some of the bunch grasses coming up, but not nearly the large coverage that we got from the fall straw seeding treatment. Okay, so here's a graph. Here's our percent herbaceous cover, and the blue is our control. The gray is our fall seed and rice mulch, and the green is our winter seed and wood mulch. And I'm just going to draw your attention first to this section. So you can see that the fall seed and rice mulch increased herbaceous cover in the spring and the following winter. Give you a moment to look at that. But that by spring 2017, herbaceous cover was similar in all treatments. We still have, a difference of 20% between, a little under 20% between the control and the fall seed rice mulch, but you can see the winter seed wood mulch is starting to catch up too. So here's what all the treatments looked like by spring 2017. So we've got coverage on all three of the sites. In the control, I'm seeing shrubs and trees regenerating. But, here we are this is probably taken May 5th, I think. The non-native annual grasses are already starting to turn brown. And then the perennial grasses have, really started to establish. So in there, I can see Bromus carinatus and Elymus glaucus, those two species that we call our workhorse species, with pretty good coverage. So does seeding after fire increase vegetation cover? I would conclude from this that yes, initially, and that prompt fall reseeding with straw mulch, take it or leave it for whether you call that, a treatment that we tested, had the strongest impact. So initially, seeding after fire increased vegetation cover, and the fall reseeding definitely had the strongest impact initially. Next, we wanted to look at whether seeding after fire reduced sediment loss. And we know that that's a huge issue because it causes all kinds of monetary and social challenges, having flooding and erosion. And so, we really wanted to look into, do our seed mixes actually impact that? So we modeled sediment loss using the revised universal soil loss equation, which is commonly used by agencies in California. It's called RUSL 2. And we modeled that sediment loss from erosion from 2015 to 2020. And so the way this works is you take, the software, which can pull location-specific data, so things you don't need to enter because you just kind of give it the location, and it can go into several different databases and upload different variables. And then there's user inputted data, so going out and actually having to measure things. And so this location-specific data that we looked at included climate, soil type, slope steepness, slope length. Those are all things that are, there's a database that we can utilize. But then we also wanted finer detail topography, yield. So we measured residual dry matter production level. That's kind of the biomass of plants above ground, rock vegetation cover, and then we inputted the type of mulch and the amount that we put in there. Okay, so here comes a really big table. I'm going to walk you guys through it. So here are the results of our erosion sediment loss modeling. The untreated control, you can see the average annual soil loss tons per acre per year was 27.6 tons per acre per year. And then you can look down to the first 5 years. So initially, the first year we got about 64 tons per acre, down to 43, 17. By the time we got to 2019 to 2020, our models were indicating it would be about 5 tons per acre per year. Oops. Here's our fall seeding plus rice mulch. So you can see there's a huge difference from the average annual soil loss, driven mostly by those first few years. So in year 1, while we had 64 tons per acre per year in the untreated control, our models indicated that we had about 6.4 tons per acre per year in year 1, which reduced down to about 2.4 tons per acre per year by year 5. And then this later seeding plus wood chip mulch, initially our sediment loss looked pretty similar to the control, so 50 tons per acre per year, and then eventually started to reduce down to about 4 tons per acre per year by the end of the study. So, by the end here, we've got, not equal, but kind of ballpark similar erosion happening across all of the treatments. But if you look at that cumulative amount, there's a huge amount of sediment that would have been lost in those first 4 years. So, our conclusion there, does seeding after fire reduce sediment loss? Yes, both treatments were modeled to have strong effects lasting 5 years. And that prompt fall reseeding with mulch had the strongest impact. So one of the things, by the time you look at your 2017, the vegetation type cover versus sediment loss, I wanted to kind of go into that because by 2017, we've got kind of similar vegetation cover. So why are we seeing such a difference in sediment loss between the 3 treatments? Well, I obviously didn't directly test this, but what I would assume what's going on is the type of vegetation is influencing this. So, as you can see in this photo, we have on the left a perennial bunch grass and its very, very deep root system. And on the right, we have an annual species that has a much thinner, shallower root system. So I would imagine that perhaps something related to the type of vegetation cover could be influencing the amount of sediment loss that we're seeing. So it's not necessarily about whether seeding increases cover compared to the control, and more about the type of cover that we're getting by that time, by 2017. So there's a ton of remaining questions, and there's a ton of things we could have done better on this. But again, I still think that there's valuable lessons to be learned. And there are a bunch of remaining questions that I have. One of the things is, did treatment impact the community composition of the understory? So, it would be really great to go back and actually look and see, whether that sort of hypothesis I have is correct, whether the community composition of the seeded areas is highly dominated by perennial bunch grasses versus, some of those non-native annuals. Also, I'm interested in what happened to the forbs. I'd like to see if any of the forbs have persisted over time. Native versus non-native, did any of our seeding, keep out the encroachment of the non-native annual grasses that seem to be coming in the control? Long-term versus short-term, it would be wonderful to come back now in 2023 and visit those sites and take some data. So if you know anybody who's looking for, a great master's thesis, this is the type of work that we would love to be able to do and collaborate with somebody. And then I'm also really interested in soil communities and characteristics, because one of the things that we do as a seed company is we consult on the application of mycorrhizal inoculant and slow release fertilizer, et cetera. So, it would be really interesting to look at the long-term effects of reseeding on, how soil communities recover from these high intensity fires. And again, I don't have much to offer you there in terms of our case study, but I do have some papers that I looked into that I thought were really interesting. One came out just in 2021 looking at, again, the Great Basin, where much of this post-fire research is being done just because it's so much more widely adopted there, looking at seeding treatments and comparing the reseeded areas to reference communities, sort of considered ecologically sound plant communities in the Great Basin. And then looking at how fire and fire management alters soil microbial abundance. And again, this is kind of coming out of the Great Basin as well. So sorry to you folks who are more East Coast focused, but this is what I've got. And I think it'd be really interesting to compare some of this research to any research coming out of other areas. Anyway, so just wanted to thank the folks who conducted this research, Chris Swan, who is the Environmental Programs Manager at the East Bay Municipal Utilities District, Vanessa Stevens, who is a resource analyst, and Bill Agnew. Those were both consultants who worked on this project, and then our erosion model consultant, David Leichel.
Well, thank you, Julia. That was really, really interesting. Really appreciated all the research, all the graphs that you brought to the table. Thank you. And I am catching one or two questions that are coming in, but we also have a few that have already been posed. So I am going to start asking some questions. So if you have more questions, please feel free. If you'll put them in the chat instead of Q&A, it does make it easier for, I'll be able to keep track of them a little easier. So let's talk first about, can you elaborate on the wood mulch you are using in the seed mix, please? Hardwood, softwood, age, new, chip, mulch size, etc.
That is a really good question. I would have to look into that and get back to you. I'd imagine that this wood mulch is coming from areas that we've done logging or forest thinning nearby. So that would probably be, lots of conifers. But yeah, I'd have to get back to you on that.
So was this considered a sterile rice straw?
Yes. So there are standards for certified weed-free straw that we had to follow in order to make sure we were not introducing any noxious species through our rice straw application. I highly recommend everybody do that as well, because you can end up getting the perfect seed mix and then you use the wrong straw and introducing noxious weeds.
Can you also talk a little bit about the depth of the straw and the mulch?
Sure. So as you saw from those photos, the mulch, it was like, it barely covered the seed. And I don't know whether, we were doing that at 4,000 pounds per acre. I perhaps would say we would need to be doing that a lot higher to get that, get the benefit of that. The rice straw mulch, I would say it looked from the photos like it was maybe, I don't know, a couple inches of straw initially, which I'm sure lots of it kind of tamps down or blows off. So you'd probably end up with about 1/2 inch to 1 inch of coverage.
Okay. I'm just trying to keep up. The questions are flying in.
Great.
So we have a couple more. How well does application of the 1 to 5 species of native plants compare with the application of a dozen or 2 dozen species in the final results?
That's such a good question. It's, I have a colleague, Justin Long, who's a professor at Humboldt, and he's always on our case because, he says, you always use the same 5 species in your restoration projects, and why aren't you seeding more diverse, mixes, and why aren't you designing more diverse mixes? And, in a perfect world, I think we would be putting out 20, 30 species and, kind of seeing what sticks, right? The problem is cost, and the problem is also certainty, right? Our workhorse species are kind of proven to do a good job. And when you've got this funding window and timing window, it can be really hard to go with something you're not as sure about. However, I would like to see more diverse mixes. I think the only way we're going to find new mixes or new species to try is by experimenting. And one of the things that Justin and I are working on is actually collaborating so that we can start sneaking some more species into mixes, and his research funds are going to cover the cost of those extra species so that it's a cost sharing, and then he's going to go out and do some post seeding sort of measuring of what comes up. So yeah, I think that the really diverse mixes sometimes do really well, but generally you're only going to get a few plants dominating in the end anyway. So if you know which ones are going to do well, it tends to be what we go for.
So before we completely run away from the wood chips, did you find that the wood chips were more vulnerable to washing away?
Certainly, yeah.
Okay. Did you apply seeds of plants, in this mix, or these plants that you rely on, are they deep rooted to help minimize erosion, or is it a blend of those?
So the 2 bunchgrass species, Bromus carinatus and Elmus glaucus, tend to have pretty deep roots. Stipa has really deep roots. Festuca microstachius does not, but that's kind of that cover crop one that we use. So yeah, eventually, I would say by the end of season 1, I would imagine that there's pretty good rooting happening from the bunch grasses that we seeded.
Okay. And they're naturally deep rooted. I'm not a scientist, so I'm just
Yeah.
for my own curiosity.
Yes.
And then how did soil type or typography vary in your sites? And how did you account for runoff values and success of vegetation establishment?
So we tried to pick sites that had similar topography, to similar slopes and similar soil type. So that was something we were able to control. It's not, that area actually has pretty consistent soil type. Some areas we seed, it's like it changes every few 100 meters, but this was actually pretty uniform. So that allowed us to kind of control in a way for that. And your question about, so we didn't measure runoff, we modeled runoff. And so that is something that, I would love to do, is actually, set up some runoff capture to sort of validate some of those models that we used. But the cover, we actually went out and measured cover.
Okay. And really curious about the ratio of grasses to forbs in your seed mix, and also shrub regan in your control by seed bank or from crowns.
Yeah, so shrub regeneration tends to be something that we kind of leave a lot to passive regeneration in our area, just because those shrubs are pretty hardy and they can withstand even high severity fires. So we didn't bother putting shrub seeds in our mix. That's not to say that it wouldn't have been interesting to try, just given our constraints. And then in terms of forbs versus grasses, again, it really depends on your goals. So for us, we really had these erosion control goals. And so forbs don't necessarily help as much with erosion control as the grasses. So that's kind of why we focus more on grasses. But looking back at that mix, that tends to be a pretty normal ratio of grasses to forbs that we use. So looking about 4 PLS pounds per acre for lupin, and actually we seeded pretty heavy on the clover. That was about 8 PLS pounds per acre.
So to the Russell model, soil loss predictions depend on the input factors. What assumptions did you use about the C factor in the Russell equation?
That is such a good question. And I really wish that I had more familiarity with this model. But to be honest with you, that was something that we outsourced to an erosion model consultant. And I'm happy to give you their email address. But back to those sort of inputs and outputs for our user input data, we measured topography. So we actually went out and did slope measurements. We measured RDM. So we actually went out and harvested the residual dry matter and were able to model. So, yeah, we assumed that based on the samples we took, we could kind of extrapolate that to the whole area. Vegetation cover, we did transects for that. And then the mulch, rice straw and amount. So, that we were assuming that what we put down was still there. That's an assumption we made because, it's like you saw some of that mulch just kind of washed away, some of the rice blows away. So, I don't know if we were able to account for that in our model. Precipitation, climate, all of that, soil type, that's things that, they just use the location of the sediment, project and sort of input that automatically. So whatever assumptions go into that model, I guess,
Okay.
there as well. Sorry.
That's okay. Was any data taken regarding the establishment of invasive species, and if either method was better at suppressing the colonization of invasive species?
So all we have are the photos. So that was one of those things where I'd love to go back now and take a look and see if there's any long-term effects of invasive species suppression. But, just based on those photos, I could see in spring 2017, there was coverage all over the control of non-native grasses. A lot of that was, let's see, it's kind of hard to tell from the photo, but I would imagine there was some Medusa head in there and some Avena, which is, not the worst, but you could see a much higher coverage of the native species in the two treatments.
Okay. We're coming down to our last couple of questions, which is good. We're kind of rounding out the hour. Have you considered ways to reduce the hydrophobic properties of soils in a post-fire condition?
Yes, that's a huge challenge, right? Because you try and put seed and mulch on, and then it just runs right off. I mean, there are several techniques that people use. Sometimes they go ahead and they mulch first and then kind of let the soil try and regain some of that and then dig it in to increase organic matter. Hydroseeding can kind of address that because it actually sticks stuff to the soil. So if you have a really hydrophobic soil, you might use hydroseeding to approach that. But yeah, that's a big challenge.
Mm-hmm. So according to CAL FIRE, Butte was a mixed severity fire. Did you select locations with similar severities for the experiment?
Yes. So we were in a high severity area. And so that was, back to our, that original research paper I was showing, that this was definitely one of those studies that got influenced by the area that needed it the most, right? The squeakiest wheel. These high severity fires were areas where we did these treatments. And so who knows what these same treatments would have been in terms of effectiveness and a slightly lower severity. And so we need to actually, start trying to do some of this this post-fire seeding in the areas that aren't quite as bad, and see if see if there are differences.
Okay. And then one question, just as in regard to hedgerow farms, somebody wanted to know if you do custom grow outs for clients. Is that some work that you all do?
All the time, yeah. So we have a full-time team of 3 people who go around collecting wildland seed from natural areas. So we apply for permits and we do collecting. We started our season actually a couple weeks ago, driving all around the state. So we'll have clients who ask us to come and collect from their areas. We bring that seed back to our farm, clean it, and then grow it. We have many contracts going at once, and we can do anything from a half acre to 10 acres.
Okay, great. That's great information. So I'm going to give you a minute to put your contact information in chat, because you've been talking and providing a lot of great information. And someone has asked if your PowerPoint will be made available after the meeting. I don't know about that. You can ask Julia if she was willing to share the PowerPoint itself, but we will definitely be sharing the recording of this program with everyone who is registered. And as a result of that, you will get the PowerPoint. That is one thing that came out of COVID is when you get the recording, you get it all. So there you go.
For sure. And I'm happy to send the link, because I know sometimes it can be hard looking through video to see things. So I'm happy to send a link to the actual PowerPoint. And again, to turn your attention to, this is actually a case study that was published in the SEERCAL, Society for Ecological Restoration journal. So I do think in the beginning of this talk, we linked to that. So a lot of these figures are in that, in that paper.
Yeah, I had posted it earlier along with some other links to articles you noted, but I did just put it in again for anyone who would like to touch base with that article directly. So Julia, thank you so much. This was fascinating, wonderful work that's being done. I know the study was done a few years ago, but continuing to take that information and build on it. Thank you so much. We appreciate you being with us today.
Thank you so much. It was really an honor to get to speak with you all, and please don't hesitate to reach out. This is, something that I love to do. And, again, it's not a perfect study, but just sharing information is such the best way forward. So thanks for hosting these types of case study opportunities.
Absolutely. We're all better together, right?
Yes.
And that's why NAA is here. So
Great.
thank you so much. And
Right.
the email is in chat. If you just go just up a little bit, Julie did put her email, but if not, you can email info@naturalareas.org. We'll be happy to share it with you. Okay, everybody. Thank you so much. Have a great rest of your week.
All right.
Bye.
Bye.